Welcome back to Easy Academic. In this episode of the Linear Algebra 1 series, we'll be going over the cross product. Now, the cross product is a concept that's a lot more easy to understand in 3 dimensions than in 2. And so we'll start by creating two arbitrary vectors, A and B, in 3 dimensions. So we'll have A is equal to A1, A2, A3, and B, which is equal to B1, B2, B3. And so the formula for the cross product is A cross B equals A2 B3 minus A3 B2. This is the first entry. Your second entry is A3 B1 minus A1 B3, your second entry. And the third entry is A1 B2 minus A2 B1. And so the cross product gives us a new vector, whereas the dot product only gives us a scalar value. Now, this might be difficult to memorize, and so a trick that I've learned is as follows. So what you want to do is you want to write out A 3 times, A1, A2, A3, A1, A2, A3, and then do the same for B. So B1, B2, B3, B1, B2, B3. And you want to start at A2 and draw these arrows. And you can draw them in different colors if that makes it easier to visualize. So you have these two, which correspond to one another. Let's take a new color, green. These two will correspond to one another. Let's take blue, and these will correspond to one another. And each new color represents a new entry in our final matrix. So our final matrix, A cross B, will be equal to your first entry, which is A2 B3. You always start on the left. So A2 B3 minus B2 A3, which if we compare to up here, you notice it's A2 B3 minus A3 B2. It doesn't matter which order you multiply it, and you'll still get the same answer. And your second entry will be A3 B1 minus B3 A1, which you'll notice is the same here. A3 B1 minus B3 A1. And your third entry will be A1 B2 minus B1 A2, which is the same as here. And so you'll observe that this trick works in 3 dimensions as well. So let's compute an example. Let's say A1 is equal to 1, 0, 0. Let's say B is equal to 0, 0, 1. When we take the cross product of these two vectors, we'll obtain, as here, we'll obtain A cross B. A cross B is equal to A2 times B3, which is 0, minus B2 times A3, which is 0. The second entry, A3 times B1, which is 0, and B3 times A1, which is 1, so you'll get 0 minus 1. And you'll find that A1 times B2, which is 0, and B1 times A2, which is 0. And so you'd find A cross B is equal to 0, negative 1, 0. So this is an interesting resulting vector that we've obtained. So what necessarily does it mean? What the cross product gives us is a new vector, A cross B, which we can call C, that is perpendicular to both A and B. So you'll observe that these two are unit vectors or basis unit vectors in R3. This is a corresponding negative basis unit vector. So it points in the opposite direction to the standard unit vector, and that's because we did A cross B. The order in which you do your cross product matters because say we did B cross A, this would be a positive value. And so this represents two things. First, as I mentioned, this gives us a vector that is perpendicular to both A and B. And secondly, if you create a parallelogram, and secondly, if you create a parallelogram out of A and B in 3 dimensions with A and B as the side lengths, you'd find that the area of this parallelogram would be given to you by the magnitude of A cross B. And so in this case, the magnitude is 1. And so the area of this parallelogram is 1, as you might be able to intuitively see, since the side lengths are both of length 1. I hope this video provided you with an intuitive understanding of what the cross product represents. If you have any questions, be sure to leave them in the comments. Be sure to like and subscribe, and thank you.